Now you are going to learn the third application of dimensional analysis. In this case, you are going to derive the expressions by reading a problem. Now I am going to solve one problem. That problem number is 1.15, which is given here. So in this problem, various physical quantities are given. All physical quantities to be related by an equation with the help of dimensional analysis. For that, I am going to do one problem. I will read the problem first. What is given in the problem? Obtain an expression for the time period t of a simple pendulum. You are going to derive the expression for time period of the simple pendulum. Therefore, t is given. What is t? Time period t. The time period t depends on three factors will be given now. The time period t that depends on the first one, mass of the simple pendulum, mass of the bar. The second one, length of the pendulum. The third one is acceleration due to gravity. So here, as per the problem, these things are given. Here, the time period, mass, length and g all are simply is clear given without any relationship. Here, by solving the problem alone, we will come to know that how they have to be related. Are you clear? Finally, you are going to derive the expression t is equal to 2 pi square root of L by G. This is the formula. Often we are using the formula in the practical to calculate the time period of the simple pendulum. Now we are going to derive this formula. Now I have given the answer of the problem. Look at that. Time period is simply, it is given that it depends on mass, length and G. Here, before going to start the problem, this step must be written and it should be taken as step number 1. How will you write this step number 2? This t should be equated with by introducing a constant k. Right, k, that is a dimensionless constant. Here, in the case of m, mass, you have to write some power. Let us assign some power here, x. For L, the power can be written as y. For acceleration due to gravity, you can assign the power as z. Here in the next step, the second step can be assigned as 2. Here you have to write k, x, y and z. All are called as dimensionless constants. Dimensionless constants. You have to write like this. This step is the must one. Are you clear? Here in the problem, the k value is given. The k value is how much? As per the problem, 2 pi. K value, if any constant is there, its value will be given in the problem. So what will be the next step? You are supposed to know all the dimensions of all the factors must be known. What is the dimension of time period? The dimension of time period is capital T. That must be written within the square bracket. What is the dimension of mass? Dimension of mass is capital M. Capital M must be written within the square bracket. What is the dimension of length? Dimension of length is L. What is the dimension of acceleration due to gravity? Lt power of minus 2. So all dimensional values must be known. Only then you can solve the problem. Okay. Now in the second step, you have to substitute all the factors here. Instead of time period, substitute the dimension, t is written. Finally, you can write the value of k. Are you clear? Write the k value here. And then m. The dimension of m is m. You simply write x at the top. L. Dimension of L is capital L. The power is y. Instead of acceleration due to gravity, substitute the dimension of g. So all the dimensions are substituted. What will be the next step? Here, just for the convenience, I am going to make some alterations here. Here, the time period does not depend on mass and length. Therefore, since it is not depending on mass and length, we can write it as m power of 0. L power of 0. But time to clear factor alone is there. Therefore, you write it as 1 and everything must be written within the square bracket. Substitute k. Now, you have to choose the m alone. Are you clear? You have to choose the m factor. For that, you have to find out what is the power. Here, you take m. In other two factors, m is not there. So, what will be the power of m here? X. So, simply write x. Next step. Here, L is there. In the first factor, L is not there. But in the second factor, L is there. Therefore, write L. Here, what is the power of L? Y. Here, what is the power of L? 1. 1 into Z. Z. And then add it. So, what I have done here? I have to write M, L. Next, I am going to write T. First, you have to write M. You have to choose all the powers of M. They have to be added. You have to choose the powers of L. All have to be added. Next, I am going to choose the powers of T. Everything to be added. Here T is not there. Here is also T is not there. Here alone T is there. So multiply this minus 2 with Z. You will get minus 2Z. Are you clear? Now, just for your convenience, this is the first time we are doing the problem now. That's why what I am going to do, I am going to equate the powers of M on LHS side and RHS side. So what is the power here? 0. What is the power here? X. This 0 must be equated with X. Are you clear? Now I will write the equation. This X is equal to 0. So this is written first. The power of M in RHS and the power of M in the LHS both are equated. Now I am going to equate the powers of L. 0. This to be equated with Y plus Z. Are you clear? So how will you write? The next equation can be written. Y plus Z is equal to, that is also equal to 0. Are you clear? This one, here t power of 1 is there, here t power of minus 2Z is there. Equate them. This one can be equated with this. Are you clear? Just we are comparing. The third equation can be written as minus 2Z is equal to 1. Now we have to solve the equation with the help of algebra, and finally we have to get the values of x, y and z. X is already ready. X is equal to 0. With the help of z we can write z is equal to minus half. So z is also ready. Substitute the value of z in this equation. Y plus z is equal to 0. Y minus half is equal to 0. Therefore, y is equal to half. So, y is also ready. Are you clear? So, now if we have found the x value, y value and z value, all the x, y, z values must be substituted in the equation 2. Are you clear? Now, substitute x value, y value and z values to be substituted in equation 2. How will you substitute? Let's see that t is equal to, instead of k now you can substitute 2 pi. Substitute here m power of, instead of x, what is the value of x? 0. And then L power of y. L power of y is, power is half. And g power of z. Z value is minus half. So everything is written here. Anything power 0 is 1. Therefore m won't be present now. So anything, if any is clear, 0 is there as the power of any factor, that one becomes 1. L power of half can be written as square root of L. G power of minus half means that should be brought down to the denominator, but square root must be written. Look at the equation now. Now you have got a new equation. T is equal to 2 pi square root of L by G. So the final expression is, the final obtained expression is T is equal to 2 pi square root of L by G. So finally it is concluded that the time period of the pendulum is directly proportional to the length of the square root of the length of the pendulum, and time period of the pendulum is inversely proportional to the square root of the pendulum. Again, I would like to repeat, time period is directly proportional to the square root of the length of the pendulum. The same time period is inversely proportional to the square root of the acceleration due to gravity. Are you clear? Any doubt on this? So, the main conclusion is the time period does not depend on the mass. Time period that depends only on the length of the pendulum and inversely proportional to the square root of the acceleration due to gravity. So time period depend only on L and G, not depend on mass. Initially, this conclusion was not given in the problem. Simply it is mentioned that time period is depend on mass, length and G. After deriving the formula alone, we are able to conclude how they are all related. So this is the purpose of using the dimensional analysis, from which we are able to derive the expressions in physics. Okay, thank you.